Hi girls, we're going to talk about derivatives of exponential functions. But first, here's a rose that I grew in my garden. Okay, so we've done exponential functions before. Here's a collection of them in colour. Few things to remember, they all pass through the points 0 and 1. They lie above the axis for all of x. They're quite similar in shape, and the defining characteristics come from the number that's raised to the power of x. Okay, that's just to put the function in the picture when we do the differentiation. In some ways, this is the easiest function to remember when we're differentiating. If f of x equals e to the x, then f dash of x also equals e to the x. In other words, it doesn't change. So our work mainly focuses around this second version of the function, where we have e raised to another function. So for example, e raised to 4x. In that case, the derivative is the function e to the 4x multiplied by the derivative of that function times by 4. It's a version of the chain rule. Let's see how it works. Alright, so I've got e to the power of 2x. So the derivative of e to the power of 2x is e to the power of 2x multiplied by the derivative of 2x, which is 2. And that gives me 2e to the 2x. How about you try the second one? Stop the video and you have a go. Okay, so y dash equals e to the minus 1/3 x multiplied by the derivative of the minus 1/3 x, which is minus 1/3. Okay, e to the x squared. So we get the function itself multiplied by the derivative of x squared, which is 2x. So we have 2x e to the x squared. 4e to the 3x. And we get 12e to the 3x. And finally, e to the minus 2x. Okay, so they were some introductory ones. Let's look at some harder ones now. We've got 2e to the x plus e to the minus 3x. So dy dx is going to be the function multiplied by any function above. So not in the first case. In the second case, e to the minus 3x, we're going to multiply by minus 3 and end up with 2e to the x minus 3e to the minus 3x. Okay, x squared e to the minus x. I need the product rule, but why do I need the product rule? Well, it's because I've got one function, the x squared, times by another function, e to the minus x. So I've got a product, which means I need the product rule. So what's the product rule? dy dx equals vu dash plus uv dash. Okay, u first, then v. So e to the minus x, brackets, derivative of x squared is 2x, plus u x squared times v dash. So e to the minus x, keep the whole function, multiply by the derivative of that negative x, which is negative 1. Beautiful. Now we can tidy up a little bit. 2x e to the minus x minus x squared e to the minus x. We can even factorise out an e to the minus x and an x, which leaves us with 2 minus x. Good job. Okay, we have e to the 2x all over x, which means I need my quotient rule because I've got a fraction. U on the top, v on the bottom. Quotient rule. So dy dx equals vu dash minus uv dash all over v squared. So v, which is x, u dash, so we keep the whole fraction, e to the 2x, multiply by the derivative of the 2x, which is 2, minus u, e to the 2x, multiplied by the derivative of the x, which is 1, all over v squared, which is x squared. Okay, let's just tidy up. We've got 2x e to the 2x minus e to the 2x all over x squared. And I'm going to factorise out the e to the 2x. 2x minus 1 all over x squared. Okay, now what have we got here? We've got a function that's raised to a power. So what's inside the function can be differentiated, but we've got a power. That tells us we need a chain rule. So dy dx, we're going to bring down that power, bring down the 3, keep that inner function, decrease the power, and now differentiate what's on the inside of that function. So differentiating e to the x is e to the x. So we end up with 3e to the x, e to the x minus 1 all squared. Now this question needs you to be a little bit creative. It becomes clear when we write this in this format, because now we've got a function inside of brackets raised to a power, which is a chain rule. And we can differentiate it using the chain rule. So we bring the power down, decrease the power by 1. So everything stays the same. Decrease the power by 1. Now differentiate what's inside the brackets. So 2e to the minus x multiplied by negative 1 And just tidying up a little bit. Well done. So have a go at some questions in the textbook. On the next slide are these solutions, the work solutions for all the questions relating to this.